Hi, welcome back to That Was Physics. Today we're going to be talking about the sign convention of velocity and acceleration of an object moving with uniform acceleration. First of all, to be consistent in your use of the sign convention, we have to know this iconic sentence, which says that start with V because V decides A. What does that mean? Well, first of all, we have to start with deciding the sign of velocity because velocity decides the sign of acceleration. And something else we need to know that as long as the object is speeding up, velocity and acceleration match signs. They are going to match signs, whatever the signs are, positive, or even negative. And whenever the object is slowing down, that simply means acceleration must take the opposite sign of velocity, whatever the sign of velocity is, positive or even negative. Alright, we have to retain this because we're going to need this right now in these examples. We're going to just speed up, slow down to the right, speed up, slow down to the left. So let's see. Let's speed up to the right, for example, from 10 meters per second to 20 meters per second. Now, by convention, we see that moving to the right is the positive direction. Therefore, here, velocity is going to be positive because we're moving to the right. But we have to ask ourselves a simple question here. Are we speeding up or slowing down? So speeding up simply means A must take the same sign of velocity. Therefore, here, acceleration is going to be positive as well. Let's slow down to the right, for example, from 20 meters per second to 10 meters per second. Alright, now we still move to the right. We are still moving to the right. Therefore, velocity is going to be positive even though we are slowing down to the right, but eventually we are moving to the right. So, the usual question, are you slowing down or speeding up? Now we are slowing down to the right. Therefore, acceleration must take the opposite sign of velocity, whatever the sign of the velocity is. So that velocity is positive, therefore acceleration is going to be negative. Alright, now let's speed up and slow down to the left. As you can see, for example, from 10 meters per second to 20 meters per second, now moving to the left is, by convention, the negative direction. Therefore, velocity here is negative because simply we are moving to the left. Alright, and we have to ask ourselves the usual question, are we speeding up or slowing down? Now we are speeding up but to the left. Therefore, acceleration is going to take the same sign of velocity no matter the sign of the velocity is. If it's negative, alright, acceleration is going to take it because we're just speeding up. And let's slow down to the left. So velocity here is going to be also negative because we're just moving to the left even though we are just slowing down. But as we are slowing down to the left, acceleration here is going to take the opposite sign of the velocity. So that acceleration is going to be positive. So let's take a closer look here at this and this one. No matter which direction you're moving to, but as long as you're speeding up, the sign of velocity and acceleration match. And here as well, we're speeding up to the left, acceleration is taking the same sign of velocity. But right here, they did not match because simply we're slowing down. And here also they did not match because we also are slowing down, but to the left. Alright, if we actually understand this, let's apply the same rules to another example of an object under free fall motion. So let's see. Right here, this ball is going to be thrown upward, and then it's going to reach up to the maximum height. Its velocity is going to be 0, and then it changes direction back to Earth. So let's see. To better understand this problem, we have to just break it into two parts. So let's do it. The ball moving upward and then downward. By the way, by convention, we say that moving upward is the positive direction for velocity, therefore velocity here is positive. But slow down. We have to ask ourselves the usual question: are you slowing down or speeding up? My students tend to say, as the object moving upward, that simply means it's speeding up. I used to tell them, if the object were speeding up, going upward, why wouldn't it go to space? And they figure this out, that the object going upward in the air, that simply means it's slowing down. So slowing down, acceleration, which is here acceleration due to gravity, is going to take the opposite sign of velocity. Therefore, acceleration due to gravity here is negative. Alright, what about the object going downward? By the way, downward, by convention, is the negative direction. Therefore, velocity is going to be negative, and as you are going downward, now we understand that the object is going to be speeding up, and speeding up simply means acceleration is going to take the same sign of velocity, which is here negative. Therefore, it's going to be negative little g, right? So as long as you're speeding up, they're going to match. As long as you're slowing down, they are not going to match, right? Here, speeding up. And that's it. Let's call it a day, and thanks for learning with me today. I have enjoyed learning with you. See you.